hardware design of a sensor node. So, we have seen that a wireless sensor network consists of large number of sensor nodes, and then it is all about establishing wireless communication between these sensor nodes, so that the data that is sensed by each of these sensor nodes could be transmitted through a multi-hop path to the intended destination node, the base station, and so on. So, the main problem is how do you design a wireless sensor node. So, it can be designed in two different ways, in fact many different ways. If we are talking about a regular wireless sensor node, a embedded system based wireless sensor node, this is what we are going to cover now, but MEMS based wireless sensor nodes could also be designed. Additionally, nano technology, NEMS based nano embedded NEMS based technology could also be designed. So, MEMS is at the micro electromechanical system, and NEMS is nano electromechanical system. So, both micro scale and nano scale devices could also be designed, but we are not talking about the micro scale and the nano scale devices now. We are talking about designing wireless sensor nodes at the normal scale, which are little bigger in size, but this is the first thing that one could do more easily without, in the absence of existing technologies for MEMS fabrication or NEMS fabrication. So, there are different characteristics and requirements of wireless sensor nodes. They have to be energy efficient, low cost, distributed sensing should be supported, should be able to operate in high volumetric densities, be autonomous and operate unattended, be adaptive to the environment, should support wireless connectivity, multi-hop communication and distributed processing. Like this, there are many requirements and characteristics of sensor nodes. So, the main design challenge is to design how to design the sensor node in order to make it flexible and support redundancy. Redundancy is a feature of sensor networks. So, how do you design a sensor node which would be able to take care of these attributes, scalability and be able to adapt to the structural design, be reliable, be energy efficient, low cost and be as much small in size as possible. So, here is the overall architecture of a wireless sensor node. Little later on during this lecture, I am going to present to you a wireless sensor node that we have developed ourselves in our lab at IIT Kharagpur. Basically, a wireless sensor node has couple of different units. One, at the core of a wireless sensor node is the controller and memory unit. So, the controller basically does all the computations that are there. So, all the logics are implemented in the controller, and also there is a memory unit. Then what is required is to communicate. So, for communication purpose you need a communication module, and we are talking about wireless communication. So, it is a wireless module. Third is the sensors themselves. Whatever sensing has to be done, the sensors have to be attached to these sensor nodes that are developed, and then you have some kind of an energy unit which is going to power these nodes. So, we are talking about battery powered sensor nodes, so battery support and so on. Then you have the actuators, so what after based on sensing, the actuation may have to be done. So, the actuators have to be attached. GPS is optional, having an LCD screen maybe for debugging and so on is optional, or displaying the messages. These are optional things. Even the actuator is also an optional item, right. So, based on sensing, if actuation has to be done, if the requirements of the application is such that actuation may need to be done, then actuators may be required. So, this is the overall architecture of a sensor node. Now, if we talk about a wireless sensor node, these are the different units. So, as we can see from here, so first we have the power unit for power management. Then we have the communication unit for communication purpose, support of different radio network protocols. Then we have the controller unit like this, which basically hosts the operating system and also executes the different algorithms. And then for data handling and filtering, fusion of data, etc., then you have the sensing unit like this. Okay. So, these are the main components, functional components of a sensor node. So, when we talk about the controller, controller is the main one of the core units of a sensor node. The controller basically is tasked to perform different processes, execute different algorithms for control, communication, etc., etc., all different types of algorithms, different logics, and so on and so forth. So, all these things, all kinds of computation are done at the controller, and there are different types of controllers that are used in a wireless sensor node. Microcontrollers are used, then FPGAs could be used, DSP based controllers could be used, ASIC based controllers could be used, like this. There are different types of controllers that could be used in a wireless sensor node. So, here we have, the picture that we see is that of a microcontroller called ATMEGA 324, and this is a microcontroller which basically consumes very low power and uses the clock cycles very efficiently, and this is very attractive for use in embedded applications in general and sensor nodes in particular. FPGA based controllers are also attractive, particularly for parallel processing applications. Then DSP based controllers are also there. These are particularly attractive where signal processing tasks are quite heavy, however, DSP based controllers, they basically consume more energy compared to the microcontrollers. ASIC based controllers are quite popular when a specific application is there which is targeted, and for that actually ASIC based controllers are more popular. So, this is about the controllers. Then we have the memory device, which basically will store the data, right. So, these data have to be stored in the memory space. So, this device basically stores it, and there are different types of memory devices that can be used. Flash memory could be used, fuse bit memory could be used, EPROM based memories could be used. So, that is the memory unit, and then you have the communication unit. So, for communication, basically the data is received from the source node, and then once it is received, it goes through the source coder, then the channel coding is performed, modulation is performed, goes to the channel, at the destination end it is demodulated, and then channel decoding is performed, source decoding is performed, and the data is finally delivered to the destination destination node. So, there are different mediums that can be used. Radio frequency, RF medium can be used for communication, even optical communication could also be used, then infrared could be used, ultrasound could be used. All of these are different types of wireless medium that could be used for communication purpose between the different nodes in a wireless sensor network. So, I am not going to go through these in detail, but this is there for you to go through if you do not have basic understanding about the different features of these media. So, first is the radio frequency medium, radio frequency based communication, where different electromagnetic waves are sent from the source to the intended recipient, and so there is some kind of antenna that has to be designed. So, these antennas are going to send the RF signals from the source, and these RF signals are going to be received at the recipient, where they have to be decoded and further demodulated, etc., in order to get meaning out of the information that is sent. Optical communication, laser based line of sight communication, it is basically more popular for line of sight based scenarios, and these basically spend less energy than radio communication, but at the same time, as we have seen that wherever there is line of sight, optical communication could be used, but not always. Another advantage is that there is no necessity for use of separate antennas for optical based communication. Infrared is also very popular. It's a communication that is directional in nature. That means that it travels in straight lines. There is no need for antenna, and the communication range is very short. Very short means less than a meter or so. Ultrasound is also quite popular. Particularly when you have when you have medium in between the source and the destination. That means that maybe a concrete wall or something like that, ultrasound could be used, because ultrasound basically penetrates the concrete walls as well. The transceiver is the unit which takes care of the communication, transmission and reception both. So the transceiver basically takes care of offering services to the upper layers by in the form of sending packets, bytes, bits, etc. So the transceiver basically has different other characteristics as well, lowering the power consumption, because normally transceivers basically consume lot of power. They are quite power hungry. So a good transceiver has to be designed which can consume less power for their use in sensor networks. The transceiver basically can operate in these states. We can see the 4 states in the slide in front of us. So it can be in the idle state, it can be in the transmit state, receive state, or the sleep state. So transmit state is basically ready to transmit data to the neighbor nodes. Whenever the node is basically ready to transmit data to the neighbor nodes, it is in the transmit state. Receive state, the node is ready to receive data from the neighbor nodes. If the node is in the idle state, it is ready to receive, but is actually not receiving the packets, from other nodes. And sleep state is basically when the transceiver is switched off. So it is the sleep state. The transceiver is switched off, but at the same time sensing is going on. So sensing is going on if if this particular transceiver which is in the sleep state is attached to a particular sensor node. Sensing is going on, but the transceiver is in the sleep state. So these are some examples of different communication modules that could be used in a sensor node. ZigBee based communication could be used, which is quite popular. In fact, ZigBee is quite popular for use in sensor nodes. So ZigBee is based on the standard IEEE 802.15.4, which is basically good for indoor environments, particularly where where there is requirement of low range, low data rate, and low power consumption, and sensor network requirements. Sensor network applications basically have such kind of requirements. The second is Wi-Fi. Wi-Fi offers longer range, higher data rate, but at the same time consumes more power. And Bluetooth is good for forming wireless personal area networks, and their transmission range is up to 10 meters. And Bluetooth also consumes low power, and Bluetooth is based on the standard IEEE 802.15.1. Different types of, those were the communication units, communication modules, different types of communication devices that could be used, and the standards and so on. Now let us, in a sensor node, we have the sensors as well. So the different types of sensors based on the application could be used. Sensors which are scalar in nature, like vibration, which can be measuring the vibration, the temperature, pressure, and so on, or sensors which are vector based. So camera sensors are examples of vector based sensors. So scalar sensors, temperature, vibration, atmospheric pressure, etc., and vector based are basically camera sensors are an example of that. So whatever be the type of sensor, it is important to design sensors which can give maximum sensing range as much as possible. Typically, the sensing range is quite low, only a few meters and so on. But what is important is to design the sensors and deploy them in such a way that the area that is going to be monitored is going to be covered properly. So, there are operating systems that are also used in the sensor nodes, the embedded operating systems, and this is like the normal operating systems, but these operating systems, the EOS, the embedded operating systems, are used for embedded devices like wireless sensor nodes. And these embedded wireless sensor devices, they have small memory footprint, they are efficient in power as well as computation, power consumption and computation. There is they basically support typical embedded applications are real time in nature. So, they support real time applications, they are robust and they support diverse different types of applications with and they come in different types of designs. So, these embedded operating systems could be based on event driven model, thread driven model, and each of these they have their own advantages and disadvantages, which I am not going through, but it is there for you to go through and have a feel of it. So, everything fine. So, we have a communication unit, we have a sensing unit and so on, but then something has to power these nodes. So, we had computation done using the controller, communication using the transceiver unit, and then we have the memory unit which stores the data temporarily and so on. So, but overall this node has to be powered with some kind of batteries typically. So, these batteries, it is good if these batteries are rechargeable batteries. However, it is not necessary that the batteries have to be rechargeable, but so basically the primary batteries are not rechargeable batteries, but secondary batteries are rechargeable, and particularly if there is a requirement of an application which has a requirement of energy harvesting, so maybe from solar or maybe from wind or something like that, then these secondary batteries are required because they are rechargeable, and once the energy is depleted, energy can be harvested from the environment and energy can be restored in those batteries. So, energy supply, it has to be low cost, high volume, lightweight, and with less recharging time and long lasting for making them useful for use in sensor network applications. So, these sensor energy supplies, sensor node energy supplies, they should also have low self discharge rate, because self discharge is something that we are already familiar with. So, basically when you have a battery which is fully charged, you leave it doing nothing, it is going to discharge out of its battery on its own. So, these batteries that are going to be used for powering the sensor nodes, they should have low self discharge rate. They should have long shelf life and they should support different types of voltages, different voltage requirements. Different types of hardware platforms are possible for use. Typically system on chip SoC sensor nodes are possible. Augmented general purpose personal computers, PCs are possible. Dedicated sensor nodes could also be developed, and the corresponding examples belonging to each of these hardware platform categories are mentioned over here. Just in the interest of time, I am not going to mention each of them individually. So, these are the different types of sensor nodes, as I said. Now, I will give you an example of a sensor node that we have developed in our lab, the SWAN lab at IIT Kharagpur. So, the SWAN lab basically has designed this sensor node. So, let me just point out using the mouse the different parts of the sensor node. This is the sensor node, and we have already seen that a sensor node needs to do certain computations, right. So, these computations can be done with the help of this controller. This controller can help in performing different computations. Then we have seen that some kind of transceiver unit is used. So, by the way, this controller that we have used is the ATMEGA controller, and we have a communication unit for sending the sensed data, and over here it is shown that we are using the ZigBee communication unit, but it does not have to be ZigBee. One could use other types of communication units based on maybe Wi-Fi or even GSM based communication and so on. So it depends on the application, the nature of the requirements and so on, what type of communication unit is going to be used. For sensor to sensor node communication, typically ZigBee is good, but from sensor node directly to a base station, some long range communication such as Wi-Fi or GSM is better. So this is basically the USB charging or even the USB, not necessarily for charging, but USB device which can be connected to a computer for maybe transferring the data from the node to the computer or from the computer to the node. This is basically the programmer that could be used. Once you have written the code, the microcontroller code, it has to be burnt into the microcontroller, right. So for that the programmer comes handy. So programmer basically will help in burning the code that is written in your PC into the microcontroller. Then we have over here we have this is the display unit, which is an optional thing, but it is good to have if you are if you want to show something, if you want to display, if your node has to display certain messages for users to understand what is going on, or even for debugging purposes, the display unit is good, useful. And then you have all these power units. This is the this is the charging point for the batteries to be recharged. So the power basically the power input can be made from here, and these are the on off switches which can be used for switching on and off the sensor node. And this is on the other side, this is showing the rechargeable batteries that are used. So these are the batteries that we have used for our general purpose sensor nodes, but one could use different other batteries, a small sized battery, depending on the requirement for which the sensor node is fabricated. So this is the general specifications of the sensor node that we have developed. ATMEGA 324 processor is used. Then the clock frequency is up to 20 megahertz. Power consumption in the active mode is 60 milliamperes at 5 volts input, and in the sleep mode it is 100 microampere at 5 volts input. Then 10 bits 8 channel ADC is used, analog to digital converter. And 2 USART and USB connectivity. These are the different specifications of the sensor node that I had just shown you, the one that we have developed in our lab. Here are a few other specifications. I am not going to go through them individually, but it is there for you to just read and trying to have a feel of the nature of the sensor node that we have developed. And these are the different features of the SWAN sensor node. It is flexible, supporting debugging, etc. The users can also be able to see the messages, what is going on and so on. Users can change the wireless module as per the specific requirements. So it is flexible in that sense. Users can change the wireless module. Instead of ZigBee, you take the ZigBee out, put maybe GSM in, GSM module in, or Wi-Fi module in. So that way, and without affecting the rest of the board, right. So you take it out and put it in the other module that you want. So it is flexible in that sense. So anytime the user can attach or detach any kind of sensor, actuator with or from the node. As the node is programmable, users can use the node in different applications, changing the firmware of the node. So just by changing the firmware of the node, this node as a whole can be used for serving different applications. So these are the state of charge in the battery using the SWAN node. So I do not need to explain with and without sensors how the charge degrades over time is shown in this particular plot. So here are some references that could be useful for you. In the book Principles of Wireless Sensor Networks, authored by Obaidat and Misra, here you will find a chapter which is titled Inside a Wireless Sensor Node, Structure and Operations, from where you can understand some of these concepts that I have covered today. So, here are a few other references, even from where you can purchase these individual electronic components. For that, actually these sites are useful. You can purchase these individual electronic components, have your own circuit design about how to integrate them in the form of an embedded device, and then it's all about the production of the device from that point on. So, this is quite not so difficult. These sensor nodes are not so difficult to make, but at the same time it is not very trivial as well. So, basically once you have some general idea from the lecture today, you can start building a sensor node of your own by purchasing these different electronic components from the sites that I have just shown you in the references. So, I hope that you have got some good understanding about how to make a wireless sensor node and the different components of it. How to make a wireless sensor node, actually we have not talked about circuit design, etc., but we have a patent filed from where you can get an idea about how to what would be the circuit design for our particular sensor node, or even you can get in touch with us. Okay, so with this we come to an end of this module on the hardware design of wireless sensor node. Thank you.